Hi there, I'm John from CNCKing.com, and today we make custom corporate awards. When it comes to making custom corporate awards, there's a lot of changes that happen year to year, and what you don't want to end up doing, that a lot of companies do, I think, as a mistake, is making the same awards every year. That's kind of boring. There's a lot of innovation that happens in a company, even my own, and to have the same thing year after year after year is just, put a little bit of creativity in your stuff, basically, is my idea of it. So this year we made corporate awards that are somewhat similar process that we did last year for this company. They both have 3D printed parts, they both have wood, they both have stainless steel. Now, we did on purpose use different processes to make not the same thing but the same idea for the next year, because we just wanted something that was a bit different. So for instance, last year we made a whole bunch of fins like this using stainless steel, using the laser cutting, and this year we waterjet cut them and we painted them. So although stainless steel is stainless steel, this is different. For the wood, last year we used maple, this year we used Douglas fir. Again, it's still wood, just has a different texture, look and feel and that kind of stuff. Same thing with the 3D prints, a little bit different. So everything's just slightly different, just to show right away, well, I know what year this was from and I know what year this was from without even reading anything on the award. So the first part of making these custom awards was actually choosing which material we're going to use. And that was pretty straightforward. We already had a process that worked previous year, so this year we'll just do the same but different. So when we went ahead and started making the thought process behind it, we wanted a different wood. Last year we used maple, which came out great. So this year we used balsa, which is this year, and Douglas fir. A little bit heavier, but here's Douglas fir. And they all have a plus and a minus to them. So Douglas fir has a very strong grain. Balsa is kind of a boring grain. There's not much going on there. So visually speaking, after we did the prototypes, right away we knew, we're going to make it out of Douglas fir. Now, when it came to other aspects of the award, last year the blades were sort of going like this, and there were a whole bunch of them. This year we just went with two. One of them in the front was not painted, the other one was painted. The 3D printing aspect of it last year was locked in. This year you can actually take it out and put it back in, or screw it in, screw it out. So there's a whole mechanism for that that the customer produced themselves. When it comes to CNC routering wood, I generally don't have too many issues with the machine that I have now. A couple of machines ago, I'd always have issues where something would go flying off. So I didn't have a vacuum table. You'd have to use screws, and sometimes you run over the screw and all those kind of things. In this case here, I have a very strong vacuum table, so it literally just sucks it right down. All the boards you see going around the piece of Douglas fir that you see here are actually just to stop the vacuum from going over there and losing suction. So everything is focused only where that beam is. The advantage to that is it just doesn't move. You can't even rip it off with your own hands, which is what you want, especially when you're doing something like this here, because I'm machining almost all the way down, and there's more sawdust that I'm making than there is sawdust left in what's after production. So basically, everything you see me carving out here, there's less wood in that than all the sawdust all the way around from that. Now here is the balsa that you can see being machined. Again, same design as the other one, same process, nothing changed. The nice thing about having a tool changer when you're doing this kind of work is that you can just quickly change tools, and it dramatically speeds up production. I used to have CNC routers, even a 5x10 table, without a tool changer, and I could not live without one now because I use it so extensively on so many projects. It's just an amazing tool to have on a CNC router. So what you see here are actually the blanks of the awards. The reason why they're staying inside of here is because they're very, very thin skin. And the reason for that is because these are relatively small. So although I do have a very powerful vacuum system, the issue might be that the bit might just grab a little bit of it because it has such a very strong grain, and that'll just go flying across the shop. So by having it this way here, it's a little bit more work because now I have to take them out, but that's quick work to do with the bandsaw. But then I'm guaranteed that these are all perfectly circular and perfect to spec throughout the whole production. Another thing to keep in mind is whenever you do small pieces like this here, if you have a vacuum system, let's say these, a couple of these guys go flying off, well, you've just lost a lot of vacuum that might affect other parts while you're doing production. That's why having a thin skin on the back is very important. Another piece of Douglas fir, and this one here is the one we're actually making all the awards that you see with. It's a little bit different color, different texture, different everything, because you never get two boards the same, even if they're from the same piece of wood. If you get boards that are long enough, one end will look and feel and color and everything else different than the other end. So having smaller pieces like this here, when it comes to making production runs, produces a much better consistency throughout when you're actually making them for an award. Now you'll notice that for this project here, there is one award that's a little bit darker, and that's because it came from that first piece of Douglas fir that just happened to be darker, and we needed an award that was a little bit more contrast to the other ones, so that's what we ended up doing for that. Whenever we do this kind of work here, you can see it's very methodical. The router just goes back and forth, back and forth. Before I did all of this kind of work, I actually flattened the table. So I knew the table was completely flat and parallel completely to the head of the router. Now, I've had other routers before where I couldn't really do that, or it wasn't dead on all the time. And then you'd see marks and you have to sand it off. With this machine here, it's been spectacular. Absolutely perfect, dead, flat. You can't even tell where the passes were, and when you're doing this kind of work here. And what you see going along the top there of the spindle are actually additional tools, and you'll see that one is filled, and you see the other ones that are empty, and that's all I have left on a 19 tool changer regarding how many other tools I can start using before I have to start manually moving tools in and out of the machine. So what it's doing now is, after the initial flattening, what it does is carve out the inside, because that has to be totally dead perfect because it has a 3D print going into it. Then after that I do the steps, and then I go ahead and carve out the outside. Now it doesn't have a chance to move because all of this happens relatively fast, and as soon as I have that done, I send it to the sander and I sand everything nice and flush so that I can start doing the laser work. So the top of the awards was actually made out of stainless steel, 12 gauge, 304. And normally what I always tell customers is, if you're gonna go with stainless steel, there's no point painting it, go with mild steel. And the reason for that is because if you're gonna pay a premium for a material, you might as well show off that material instead of painting and covering it up. In this case here, we're doing corporate awards, and we thought maybe way down in the future, maybe some of the paint gets scratched off or something like that. Well, now you have an opening for rust. So we went with stainless steel and we painted it. And the nice thing about paint is you can always do a touch-up to it as well. If we just made it out of mild steel and painted it, you still have to do a little bit more work just to make sure the rust doesn't come out through behind the paint. And I want to show you here what the Waterjet looks like here. So this is the scrap from Waterjet cutting stainless steel. You notice the nesting isn't all that tight. I just needed just enough material to hold the sheet together while I was cutting it out, but not so tight that the parts would fall out into the vat. Because once you do Waterjet cutting and the parts fall into the vat, you're sort of screwed because it's gone forever. I don't know where it goes, but it's like socks in the laundry, they're gone. And this is 304 stainless steel 2B. And I don't really care too much if there's some surface overspray, underspray, all that kind of stuff, because this will end up being painted, and before it's painted, it's sanded. So any sort of issues that I might possibly have will not be there. And this is how I sand stainless steel. It actually works tremendously well. I can't think of a better system for sanding stainless steel consistently than using an orbital that's made for wood. It just works perfect. Then when you come to sanding, everything's nice and flush and flat. So last year for these awards, they're actually rectangular, and we laser engraved the front and we laser engraved the bottom of it. Now this year they're round, and the nice thing about round is now we have to go around it. So that's why I used the rotary. They went all the way around and laser engraved the details on it, and then I laser engraved the top, or the bottom I guess, to do the additional engraving. That presented some challenges though, because whenever you do a rotary, if you're off by you know, I don't know, a couple millimeters, that means the stepping action is off. That means that what you laser engrave might have some spaces larger or some overlap. There's always some issues with that, especially with wood, because you have to remember, we will cut the wood perfectly, but wood will slowly, you know, not warp, it will slowly change shape and that kind of stuff, basically environment and all that kind of stuff. And I couldn't seal the wood immediately before I did the laser engraving, because then I need to sand off the dust and the smoke that appears on the surface of it. So basically I do the router work, and then as soon as possible, go ahead and do the laser work, and then sand everything. And then as soon as possible from all of that is start doing the tongue oil. And the tongue oil seals everything in from the outside. And the 3D print went on the inside here and sealed everything nicely there really, really well. I don't show my rotary working too much here in the shop videos, because most of the stuff it does is actually pretty boring, and it's NDA and all that kind of stuff. Actually, most of it actually ends either industrial, metal or aluminum parts, or we do this stuff with wine bottles. So, you know, they want to put, this is number 5 of, you know, 500, number 6 of 500, or so forth. Serialization, or adding maps to it, or what have you. Personalization of water bottles and wine bottles and a whole bunch of other kind of bottles. So when it comes to doing this here, I have to be dead on with the circumference, because if I'm a little bit off, you notice in the marking. And every award that I did for this project here also has an engraving on the underside as well. So almost every surface of what you see is touched by a laser or a router or what have you throughout the process. Now, of course, there's some smoke generated, and that has to be cleaned off with more sanding. So once all the pieces of the award were put together, then I was put them in boxes and ship them out to the customer. Now, the customer did do the 3D printing. That's why I don't show it myself, because we didn't do it here in the shop. But it had an innovative idea, because you used a screw and two cylinders. And that allowed you to do was adjust the height of the award. So, you know, when we're putting it together, you can adjust the height slightly if you need to. But the other advantage to it is I could rotate it. So that means, let's say I wanted the award to be like this, and for some reason I wanted it to be this way. You can actually do that. You can actually rotate it around a little bit, at least. Well, if I would have locked it in with resin or glue, that's the way it is, that's done. And that's what we did the previous year. So if you're looking for custom awards, contact me at CNCKing.com. We'll make them for you, ship them right to your door.